Hello everyone, my name is Joanne Meli and this is my deep dive on BlueJ. So to begin this tutorial, I'm going to go on BlueJ's website. So you can open up any web browser, type in BlueJ into the search engine, and it will be the first website that pops up. So we're going to click on bluej.org, and as this website states, BlueJ is a free Java development environment, which means that BlueJ is a Java software that allows you to create and run different programs. Now, to be able to use BlueJ, you need to download and install the software. And there is a software for Windows, and there is also a software for Macs. So depending on which type of computer you use, you will download and install the software for this computer. So once you have downloaded and installed the software onto your computer, you can now open up BlueJ. So I'm going to close out of my web browser and open up BlueJ on my computer. And I'm using BlueJ on my Mac. So once you open up BlueJ, this screen will pop up. Now these are programs that I have created and we will deal with those later. But for now, we are going to look at the left-hand side of the screen. So to create a new program, you're going to click on the button that says New Class. And it will then ask you to create a name for this program. So in this case, I'm going to create this program with the name of Program, with the class type Class, and click OK. And as you can see, this program shows up in our screen. So now it's time to write the code for this program. So click this open, and what will show up on every new class that you create is a sample code that is already written for you. And I would like to explain to you what each part of this code means. So at the top of this code, we had words in blue, and these words are not actually part of the real code. What they are any comments you'd like to make. And the way to create these comments is you have one backslash and two asterisks, and you press enter. And you can put in any words that you want that aren't actually part of the code. So you can write your name, write the date, and you can write the name of the program. So these are just comments for you. They're not part of the actual code, they're just your own comments. So now underneath that, we have the actual code. And I will be going over the parts of this code in a couple of minutes. But as you can see, you can put comments in the actual code. As long as you put the backslash and the two asterisks and press enter, you're allowed to put comments within the code, and it will not affect any part of the code. These are just ways that you can write things for yourself, make little comments for yourself to remember what each part of the code means. Now, rather than using this code that the software provides, I'm going to use my own code to explain what needs to be included. So I'm going to open up a program called Computation that I have created. And now at the top, as you can see, we have the comments that I've made. My name, Joanne Meli, tutorial, and what this program will do. So this program will take three numbers and print the sum and average of these three numbers, which is why I labeled it Computation. So there are two main parts to any code, the class and the method. And the class is the first thing that you write in the code with the name. So you have to write out the word class and then you give the code a name. So since we gave this code the name Computation, that is what you write right here. You will write the word class and then you will write the word Computation. And once you have created and titled the class, it is now time to go into the main method. So the main method will always begin the same way, with the words static, void, main. Then a parentheses, string, with two brackets, and the letters ARGS. And then we are going to close the parentheses. So that is the way that we will always start our main. And once we write these words, we put a brace, and it is time to begin writing our method. So the first thing to any method is to declare variables. So if there are any letters or words that we are going to use here, we have to declare them first and say these are the variables that we want to use. So in this case, we're going to be using the variables A, B, C, and the word sum. And these are all going to be integers, so we're going to label them as int. Because A will equal 2, B will equal 4, and C will equal 3, and when we add those all together, we're going to get a number. And a number is an integer. So A, B, C, and sum are all going to be integers, which is what we label int. Underneath that, we have the word average, which is also another variable we're using. But in this case, our average might have a decimal point. So when we want to use numbers that also have a decimal point, we label those as doubles. So the two types of variables that we're going to be using in this code are ints and doubles. There are other types of variables. There are characters. Like if you want to just use a letter A or B or C, you can label that as a character. But in this case, for this code, we have integers and we have doubles. So now that we've declared our variables and said we're going to use these, we're now going to assign values to these variables. So what will A equal, or B, or C equal? So in this case, for this code, A is going to equal 2, B will equal 4, and C will equal 3. And the whole point of this program, what we want to do is find the sum and find the average for these three numbers. So now we have to look at a little bit of math here. How do you find the sum of three numbers? To find the sum of three numbers, we have to add them together. And we have to write out this formula. So in this case, we have sum is equal to A plus B plus C. And we've already declared that we're going to use these variables, so it's okay to include it in the code. So sum equals A plus B plus C is our first formula. So now that we have the sum, how do you find the average of three numbers? Well, you take the sum and you divide it by the number of numbers, the number of variables that you're using. In this case, it's 3. So we're writing this formula out. Average is equal to sum divided by 3. So now that we've declared our variables and written out our formulas, it's time to print what we want to see written out when we run our program. And the way that we do this is with these words, system.out.println. And after these words, we have a parentheses. And inside the parentheses is going to be two parts, words that we write and our variables. So anything that we want to write will go in quotations. So in this case, we have A equals, and that's what we're writing, and it's going in quotes with a plus, and then the variable A, and then another plus, and the next part that we want to write, which is B equals, and then a plus. Now, the pluses are between every single individual part. So once you have to separate between words that we're writing and variables, you need a plus. So these are words that we're writing, a plus, and now a variable. Another plus, C equals, which is also in quotations, a plus, and then our last variable C, with a parentheses at the end, and then a semicolon to complete this line. Now the next line that we want to print out is what the sum is. So we have system.out.println with the parentheses, and then in quotations, the sum is, colon, with another quotation, plus the variable sum. And we close the parentheses and we put another semicolon. And when we print it, whatever the sum is will print. And that goes the same thing for the last line, which is system.out.println with the parentheses, the average is, colon, with another quotation, plus the variable average. And whatever the average is of these three numbers will print out. And we end that again with the parentheses and a semicolon. Now there are two things I want to mention before closing this code. And one of them is that every line needs to end with a semicolon, not just the system out print lns. Every single line that we have here, the ints, doubles, A equals, B equals, C equals, sum equals, average equals, and all the print lines, they all need to close with a semicolon, which is something that I had not mentioned before. And one more thing, I know that in the beginning of this tutorial I said that to make comments you have the backwards slash and the two asterisks. But another way that you can add comments into the code is with just two backward slashes. So if you want to just do one line, like assign values to variables, you can just do the two backward slashes and write the comments in after that. So now that we've included all of this code in, it is time to close the code. And just as we have these two braces at the beginning of the code, we need to put two braces at the end of the code. So one of the braces is to end the method, and one of them is to end the class. And with that, you have written the whole code. So now that we've written our whole code, we should check to make sure that there are no mistakes in the code. So at the top left of the screen, there is a button that says compile. And if you press it, as I will here, you will get a message at the bottom that says class compiled, no syntax errors. And as long as you get that message, that means that the code is correct, you didn't make any errors, and we can run the program. So I'm going to go to the screen that's behind this one, the one that we originally had, for our program called computation. I'm going to move it over here. Now you're going to right click the program computation. You're going to click the button that says void main with the parentheses, string, the two brackets, args, and a close parentheses. So we're going to click on that. And now inside where it says computation.main, we need to make two braces, just like we have inside our code. We click the button OK, and it will run. And this screen shows up, the terminal window. I'll make it bigger. And this is what we printed. I'll put this right next to what we wrote in our code. So A equals 2, B equals 4, C equals 3, which is exactly what we wrote in our system out print line. A equals 2, B equals 4, and C equals 3. Right underneath that, we had the sum is with the sum. And when we printed it, it says the sum is 9. 4 plus 2 plus 3 gives us 9. And the last line, system out print line, the average is with the average, it printed out as the average is 3.0. And just as I had said in the beginning, we made the average a double because it might have came out with a decimal at the end of the number. In this case, it was just 3, but if it were other numbers, it might have been 3.1 or 3.2, which is why we wanted to make that a double. So the 3 lines that we had written here for the system out print ln, they printed out right here in our terminal window. Now my content area is math, but I've also taken a few computer science courses, and I believe that BlueJ is a great tool to use in a math classroom, and clearly in a computer science classroom. BlueJ allows you to create programs for almost anything that you want. In this case, I was creating a program that allowed me to take 3 numbers, write their sum, and write their average. You can write programs that give you the difference between a few numbers, the product of some numbers. If you want to divide numbers, you can. You can put these numbers into a quadratic equation and have you print out an equation. There are endless possibilities with BlueJ, and it is just very nicely set up where you write things into a code and you make sure that you have all the components of the code and something gets printed out. So I just think that for my content area, math with a little bit of computer science, that students can really benefit from using BlueJ because it takes everything that they've learned and it brings technology into it. So yes, of course, these students have their calculators where they can add numbers if they want to, subtract numbers, and graph an equation. But with BlueJ, they can do more. They can use bigger numbers and they can include more numbers. It takes a lot of time to put 50 numbers into a calculator, but you can take these numbers and put them right into the code and you will get a result with much more efficiency than you would with the technology that's just used in math classes today. To clarify what I mean by this efficiency, I will give a specific example of how I would use BlueJ in a math and computer science classroom. So as a teacher, I would give my students the task of creating a code in which they take a function and they must find the sum and the average of the first 50 results of this function. So using just the calculator, you would have to do many steps to find these results. So the first step you would have to do is you would have to take the first 50 numbers, plug them into that function, and find those answers. To find the sum, you would then have to add all of those 50 numbers together. To find the average, you would have to add those 50 numbers together and divide by 50. Using BlueJ, you can just, in the code, type in the function, type in the formula for sum, and type in the formula for average. And then you can type in each of the 50 numbers and get your results. So rather than typing in 50 numbers 3 times over for each equation, you could only type them in once and using the formulas in your code can get all the results that you need. Now, this is just the beginning tutorial into BlueJ. As I stated before, there are endless possibilities for the codes you could write and the programs you could run, and going through all of them would be impossible. But I did want to create this video, this tutorial, to show something I would do in my content area. And there is another program I would like to show you that I would also do in the math, computer science content area. And it builds upon this computation program. However, before I show you this new code, I want to type out a code that is similar to this one, slightly shorter, because I think it'll be beneficial for everyone to see a code being written out. So I'm going to go back to our first screen. I'm going to click New Class, and we're just going to name this one Cat Dog. Click OK. And so we have Cat Dog on the screen. I'm going to open it up. I'm going to delete everything that they have inside here because it's not useful to us. Now we're going to start with our code. So I'm going to make comments at the top. Joanne Meli, Cat Dog. And those are my comments. And now we're going to start with writing the code. So we start off with class, cat, dog, with the brace. And as you can see, it showed up green. And if it shows up green, it means you're on the right track. And now we're going to go into our main method. So static void main, parentheses, string, 2 brackets, args, close the parentheses, and another brace. So now we're going to declare our variables. We're only going to use 2 variables in this one. So we're going to use x and y. And we are going to find the average, which is a double. And we're also going to find the sum. We have to make sure to put semicolons on both of those. Now we're going to assign values to the variables. We'll make x equal 5 in this case, and y equal 7. Make sure to put semicolons on both of those. Now here we have to calculate sum and average. So our sum is going to equal x plus y, and our average is going to equal the sum divided by 2.0 this time because there are only 2 variables. And now we're going to print. Need to put that in comments. So we have system.out.println, and we have x equals, in quotations, plus x, and then y equals, in quotations, plus y. Next line, system.out. Sorry about that. out.println. In quotations, the sum is plus the sum. And now system.out.println. And to get to each following line, I'm clicking enter. Sorry, I didn't state that earlier. The average is plus average. So now we're going to close the main method. It ends up yellow. And we're going to close the class, and it ends up green. And now let's compile it to make sure that we didn't make any errors. See, so this is an error that the program will find for you. So I accidentally typed average incorrectly. So A-V-E-R-A-G-E, A-V-E-R-A-G-E, they're both the same. It should work. Compile, perfect. Class compiled, no syntax errors. So that's our code. We're going to go back to this screen. Cat dog. Going to void main string agrs. I'm going to put in our 2 brackets. Click OK, and here we go. X equals 5, y equals 7, the sum is 12, and the average is 6.0. So now I'm going to open up computation 2. And computation 2 does the same thing as the first computation, which it finds the sum and the average of numbers that we have. But now, instead of having the numbers written in the code, after we run the code and we run the program, we're going to put the values in then. So what this program needs is a scanner, because the scanner takes the values that we put in after the code has been run and uses those to do whatever we ask the code to do. So to write the scanner, we need to include this outside of the class. We need to put import java.util.scanner with the quotation at the end. So the same thing, we have to name the class computation2, and then we have the brace, and then we have to begin the main method, public static void main with a thing in the parentheses and then another brace. So we start the same way. We declare our variables. In this case, we have, again, a, b, c, and sum, which are integers, and average, which is a double. But now what we have differently is that since we are putting in the number of variables after we run the program, we need to include the word final in front. So we have final int because 3 is an integer, and we're labeling this number of values. So number of values equals 3. And as I said before, we are including a scanner this time. And to set up a scanner, we write the words scanner, scan, equals new scanner, and then in parentheses system.in with a semicolon at the end. So now, when we run the program, we are going to see the words enter value 1, enter value 2, and enter value 3. And so instead of just having the numbers 2, 4, and 3 as we did in the first computation, we're going to put in those numbers, 2, 4, 3, whatever numbers we want. And to do that, we have the system out print line, which is what we had before. And now, instead of having a assigned to a variable already, we have this variable, and we are going to put the number that will be assigned to it. And to do that, we have a equals scan.nextInt with 2 parentheses, and in that parentheses, you can imagine is the number that we are going to put. So we have a semicolon. And then I included this line, systemout.println with 2 quotation marks with nothing in it. That will just give us an empty space, an empty line. So there's just some space in between the values. So again, enter value 2 and enter value 3 with the same thing. But in this case, it's b equals scan.nextInt and then c equals scan.nextInt. The next part is the same as we did in computation 1, where we found the sum. Sum is a plus b plus c. And our average is the sum divided by the number of values. And what I have here, I have the word double before sum. And I just did that so that now instead of the sum being a number like 9, it will be 9.0 instead. So it'll be a number that can have a decimal point at the end. You don't need to include that. I just did in this case. So once we have the 2 formulas written out, now we're going to write what we would print, which is a equals, b equals, and c equals. And the sum equals and the averages. And then we close the main method with a brace, and we close the class with a brace. So now before we run the program, we need to compile it, make sure that there are no errors. There are no errors, so we can compile it. So I'm going to right-click here. We have the braces, and we click OK. Now, all of this is from what we printed in our previous program. You can clear it if you want to. You can choose options clear up here, but for this sake, I'm not going to clear it. This is just what we had in the program previous to this one. So now we're at this point, enter value 1. So I'll make it enter value 1 is 5, enter value 2 is 6, and enter value 3 is 1. So then it prints it out for you. A equals 5, B equals 6, and C equals 1. The sum is 12, and the average is 4.0. So we did the same thing. We found the sum and we found the average, but in this case, we were able to print the values after we wrote the program. And that is how you use BlueJ. I believe that BlueJ is a great tool to use in the classroom, specifically a math or computer science classroom. It just takes what you can do in a traditional class setting and makes it more efficient. Instead of typing in 50 numbers into a calculator, you create a program where you can just type out the numbers on the computer, and it gives you the average, the sum, and all these other properties of these numbers. And it lays it out for you. In the terminal window, everything gets printed for you. So it's very efficient. It's a great tool to use in the classroom. You can download it very easily onto a Mac or a Windows computer, and all of your students can have access to it. And while I know that we only were able to get to 2 codes here, there are many things you can do with BlueJ that might seem a little bit confusing. So there is help online for how to document the codes. One of these websites is docs.oracle.com/JavaSE, and it helps with the documentation. So like java.applet, that's how you draw a picture. So you click on java.applet, you go to the class for the applet, and it just helps you document the code. And it's a great tool. If you don't want to use this one, BlueJ is a Java software and a Java program. So you can just Google Java documentation or help with Java documenting, and there are many resources that will show up. And while it may seem intimidating at first, there are many really cool programs you can create using BlueJ. For teachers, you can create programs that find the final grade for each of your students. You can create a program that takes a robot and makes it move back and forward, side to side. You can create a program that makes a robot change colors and dance to music. You can create programs that find probabilities for you, programs that flip coins and they find the probability of landing on heads or tails. There are programs that print sports stats, baseball stats, football stats, and they're really cool programs that teachers can use. They can implement them in their classroom, and students can work together to create a code and a program. And this ties in directly to the communities of practice learning theory, which states that it has a group of people that work together for a specific purpose. And in this case, you could have a group of students that work together for the purpose of creating a code. So student 1 in the group can work on the first part of the method, and student 2 in the group can work on the second part of the method. Because as programs get more complex and ask for more material, the codes get longer. So having students work together to create this program, collaborating together for a single purpose, is really great to use in the classroom, and it really connects with this learning theory. A specific example of this would be having a group of 3 students work together to create a code that first prints out the numbers 0 to 100 and then has a robot move back 2 feet and forward 3 feet. So student 1 can declare all of the variables in the code. Student 2 can create the portion of the code that prints out the first 100 numbers. And student 3 can create the part of the code that allows the robot to move forward and move backwards. So each student in this group gets assigned a specific task, but they're each working to create the one code, the code that runs the program, which first prints numbers and then allows a robot to move back and forth. So I hope that this tutorial was useful to anyone that wants to begin using BlueJ, and I hope that you get many great things out of the software.